How to Write Proofs, Quick Guide by Eugenia Cheng, Department of Mathematics, University of Chicago. A proof is like a poem, or a painting, or a building, or a bridge, or a novel, or a symphony. Help! I don't know how to write a proof. Well, did anyone ever tell you what a proof is and how to go about writing one? Maybe not. In which case, it's no wonder you're perplexed. Writing a good proof is not supposed to be something we can just sit down and do. It's like writing a poem in a foreign language. First, you have to learn the language, and then you have to know it well enough to write poetry in it, not just to say, "Which way is it to the train station, please?" Even when you know how to do it, writing a proof takes planning, effort, and inspiration. Great artists do make sketches before starting a painting for real. Great architects make plans before building a building. Great engineers make plans before building a bridge. Great authors plan their novels before writing them. Great musicians plan their symphonies before composing them. And yes, great mathematicians plan their proofs in advance as well. Contents. 1. What does a proof look like? 2. Why is writing a proof hard? 3. What sort of things do we try and prove? 4. The general shape of a proof. 5. What doesn't a proof look like? 6. Practicalities, how to think up a proof. 7. Some more specific shapes of proofs. 8. Proof by contradiction. And 9. Exercises. What is wrong with the following proofs? 1. What does a proof look like? A proof is a series of statements, each of which follows logically from what has gone before. It starts with things we are assuming to be true. It ends with the thing we are trying to prove. So like a good story, a proof has a beginning, a middle, and an end. Beginning, things we are assuming to be true, including the definitions of the things we're talking about. Middle, statements, each following logically from the stuff before it. End, the thing we're trying to prove. The point is that we're given the beginning and the end, and somehow we have to fill in the middle. But we can't just fill it in randomly. We have to fill it in a way that gets us to the end. It's like putting in stepping stones to cross a river. If we put them too far apart, we're in danger of falling in when we try to cross. It might be okay, but it might not. And it's probably better to be safe than sorry. 2. Why is writing a proof hard? One of the difficult things about writing a proof is that the order in which we write it is often not the order in which we thought it up. In fact, we often think up the proof backwards. Imagine you want to watch a movie at the music box. How are you going to get there? You see that the brown line will take you there from the loop. You know that you can get to the number 6 bus to the loop, and you know that you can walk to the number 6 bus stop from campus. But when you actually make the journey, you start by walking to the number 6, and you end by getting the brown line. And if someone asks you for directions, it will not be very helpful if you explain it to them backwards. Or to put it another way, to build a bridge across a river, we might well start at both ends and work our way toward the middle. We might even put some preliminary supports at various points in the middle and fill in all the gaps afterwards. But when we actually go to cross the bridge, we start at one end and finish at the other. One of the easiest mistakes to make in a proof is to write it down in the order you thought of it. This may contain all the right steps, but if they're in the wrong order, it's no use. It's like taking a piece of music and playing all the notes in a different order, or writing a word with all the letters in the wrong order. This means that for all but the simplest proofs, you'll probably need to plan it out in advance of actually writing it down. Like building a long bridge or a large building, it needs some planning, even though building a small bridge or a tiny hut might not. What sort of things do we try and prove? Here's a classification of the sorts of things we prove. This list is not exhaustive, and it's also not clear-cut. There's some overlap depending on how you look at it. 1. X equals Y, i.e. something equals something else. 2. X implies Y, or if X, then Y. 3. X if and only if Y. 4. X is purple, parenthesis, or as some other interesting and relevant property, end parenthesis. 5. For all x, p of x is true, i.e., all animals of a certain kind, x, behave in a certain way. That is, they have the property p of x. 6. There exists an x such that p of x is true, i.e., there is an animal that behaves in a certain way to have property x. 7. Suppose that A, B, C, and D are true, then E is true. Note that this is just a version of 2 in disguise. The paper continues with the general shape of a proof, but since this is all that's required for class, I will stop my reading there.